Hello, Pierre. This is a response video to Pierre-Marie Robitaille's response to Professor Dave's attacks on him. So, hello, Pierre, if you're watching this. The reason for this video is I found it very refreshing listening to that video um, where you, Pierre, took Dave's attacks apart very nicely. You were very measured. Rational is the word I'm looking for. Now, you might have to, for anyone listening to this, there might be some background noise. There is some heavy rain and other things going on. We have pets here and other things, so you might hear some noises in the background. I can't do anything about that. We'll have, hopefully it'll come through clear enough for everyone to hear and understand. Okay, in this video, this video will have some basic explanations and highlighted key points. So I will be explaining some things, basic stuff, or well, it's not exact. It's basic, but it's not basic. It's stuff that holds true always, and giving some information that maybe not everyone has thought of or knows about. And I will be highlighting then at the end some key points from the video where Pierre took apart Dave's attacks. Okay, now before I go any further, I must state, because what happens normally is when I make a video like this, or someone in my position, right, as a flat earther, I am a flat earther, and I have been since 2015, and I will be forevermore. From holding that position, when you make a video like this that involves people who are on the mainstream globe side of the debate, you are accused of thinking that you know more than these people, and that you think you're someone important and whatever rubbish, right? So I'm going to lay it out here now for anyone who is listening now. My education, right? Before I'm accused of stuff or asked about things, I left school for the age of 15, or just around the age of 15. I paid zero interest in school. I hated every minute of it, and I would never go back. But that does not automatically make me and what I say and in this video before it or any other time incorrect. The only thing that makes someone incorrect is being incorrect. So if there is any trolls or anyone who thinks that they know better or thinks that I'm not worth listening to, you're welcome to turn it off now. So you've been given fair warning. So I really don't want to be reading in the comment section of this video in the future about how I supposedly think I'm better than other people and blah, blah, blah. Education is an important thing. Education, you can learn a lot with education. But education will not teach you sense. It will not teach you logic. If you have sense and logic, then you can easily equal and defeat education. Because someone who has an education and is lacking sense and logic, then they can't think for themselves. But if you have all three, then you are an intellectual powerhouse, basically. Okay. Now, I don't mind that I don't have a big education. It doesn't bother me. It never bothered me. I never liked being in those institutions. I am very good at thinking for myself, as my YouTube name, Brian's Logic, highlights. And I am not impressed by education. I am impressed by logic and sense. That's what impresses me. Knowledge. A lot of people have education, but they don't have knowledge. I find this a lot in this flat out globe out argument, where a lot of the people on my opposing side, people just like Professor Dave, not so much like Pierre, but just like Professor Dave, they don't have all the facts to do with their model. They don't. Um, they often have to be corrected on their own model, on their own beliefs, and what they feel is our facts. They often get those things wrong. So I'm not going to go into too much about that. I just feel that that's important because I keep on getting, anytime I've made a video like this, and I've seen it from other flat earthers who made videos like this, the attack we get is, you must think you're better than these other people who are educated. It doesn't matter whether someone is educated or not. If they are incorrect, they are incorrect. End of story. Now, we'll move on. Okay, one of the main things that was spoke about in, oh sorry, just move this up here. Now, one of the main things that Pierre spoke about in his presentation is this, the ideal gas law. PV equals nRT, okay? So what does that mean? All right, let's go through it. P equals pressure, okay? Pressure is proportional to the collisions with the walls of the gas's container and other gas molecules, okay? So the pressure is defined by the amount of collisions the gas has off of the walls of its container and off of other elements of itself. Okay, people like to call them atoms, whichever, right, as a descriptive term. Okay, we can't see those things, so they can only be described. V, right, volume. V equals volume. So volume is the total area of the internals of the container, or the amount of free space the gas has to move about in. Or it could be said that it describes the restrictions placed upon the gas or gases by its container. So when you speak about V in PV equals nRT, V equals volume. Volume of what? The container. Because you can't define a volume without having a contained amount. How can you define a volume if you don't have it contained? You can't define it. So if you put gas into a 1 litre container, then its volume is a 1 litre container. If you put that same amount of gas into a half litre container, then its volume is a half litre container. That's its volume, the amount of area the gas has to operate within. Okay? N, number of atoms. Right? I'm using the word atoms. Molecules, as I said, they are descriptive. We don't see them. They're tiny, whatever it is, they're too small to see. So it's more of a descriptive term more than anything else. But there is a need for description, and that's the best that we can do at this present time is describe. So I will use the term atoms and maybe molecules from time to time. In this. So n equals number of atoms is the calculated number of atoms / molecules of gas that is within a container. So the calculated amount of atoms of gas or molecules of gas within the volume, the container. This can only be calculated. You obviously can't count them. So it's a calculation. Okay, it's a mole calculation. So R equals the gas constant, is the expected constant movement of the gas molecules. Gases are unbonded, so the atoms move about freely, and their rate of movement is determined by temperature. Okay, so it's gases. As long as a gas is a gas and not a liquid or a plasma, it will be moving. It will constantly be moving. The rate of its movement depends on the temperature, as high temperature will excite the gas and cause it to move more, and lower temperatures will dampen down that movement a bit. So, but there is a constant movement to the gas. And this kind of talks about, the gas constant is kind of talks about at an ideal temperature, it has a calculated rate, I think it is 700 meters a second or something like that. They calculated it at. But it's only a calculation. You cannot measure these things. It's just a calculation. It's descriptive again. Okay. So T, temperature, is the applied or natural temperature that is exerted upon a gas. So it's the amount of temperature that is exerted upon the gas. And that is, as with the gas constant, that determines how much movement the gas will have. Okay, just going to quick sup of water before I continue, because I have a lot of reading to do. So gravity is next. So gravity. This is important. This will make sense later. Why I'm talking about these things will make sense at the end of the video. There is a method here. Gravity. Gravity has not been considered a force since 1915, when Albert Einstein's theory of general relativity was accepted by mainstream science as the most accurate description of gravity, making gravity an effect and not a force. Einstein replaced, right, all previous descriptions of gravity, toppling the so-called Newtonian view and description of gravity from the throne. Gravity as a force of attraction between masses was officially discarded and replaced by the theory that gravity was an effect due to the curvature of space-time by mass. Excuse me. But with this came an overhaul of all previously held beliefs, right? You'll see that I'm highlighting words here in red. I want you to take close, especially Pierre, if you're watching it, take close attention to what words I'm highlighting, okay? Beliefs I have highlighted here, because unfortunately, gravity before and after Einstein is all beliefs. And this is a problem. I'll continue. As this then debunked that in the heliocentric model, okay, the Earth was being pulled past the sun faster in the southern summer due to a gravitational attraction. So Einstein's theory of general relativity debunks that, okay, because there is no mass attracting mass in his theory of general relativity. There is no force of attraction between masses in his theory. And that the moon was controlling the Earth's tides due to gravitational attraction. It also debunks that. So both of those, both the supposed in the heliocentric model that the Earth is being pulled past the sun faster in the southern summer due to a gravitational attraction, that is debunked by Einstein's theory of general relativity, and so is that the moon is controlling the Earth's tides due to a gravitational attraction, because there is no force of attraction between masses. There is no force. It's an effect. In Einstein's theory of general relativity, he does not account for more than one mass. So there is no force of attraction between masses of differing volumes. This led to the description, there's that word description, of things falling to the Earth's floor because of a gravitational attraction as incorrect. As in Einstein's theory of general relativity, the effect of an object falling towards the floor is described as the floor is coming up to meet the object, as opposed to the opposite description that was previously to 1915 held in belief. Okay, so the reason I'm being so staunch about this is too many times in heliocentrism. I don't mean this video as an attack on Pierre, right? I'm hoping he'll watch it and give me some feedback, even if he's not a fan of what I say. I would rather he watched it and gave me some feedback. The reason I'm being so staunch about this is that gravity was never anything more than a description and a belief. And I'll get to the reason why later on in the video. But that's why I'm highlighting the word description and the word belief, because that is what it is. Because if something is solid and real, then it doesn't have a need to change. Gravity seems to, all descriptions of gravity seems to continually have to change throughout time. It keeps on changing from one description to another. Soon enough, Einstein's theory of general relativity is about to be thrown out the window as soon as they find the supposed graviton, which they will find, and nobody will be able to prove they didn't. And this is a problem. So we need to deal with this as gravity is nothing more than pseudoscience. But I'll keep going. To solve the problem, I have that highlighted, it's a problem. To solve the problem of how two objects can fall simultaneously in two separate locations and be met with the same ground coming up to meet them, as opposed to these objects falling to meet the ground, a mathematical equation was inserted to solve this dilemma. So to solve the dilemma on the globe model of how me and let's say Pierre both drop our phones simultaneously in two different parts of the world. And it's described in the theory of general relativity, right, that the ground is coming up to meet the phone. So in let's say we talk about this in the heliocentric model, that would mean that as a description, the Earth is expanding and contracting as it needs to, relative to the person. So that is basically the basic understanding of it. Although it's not that the Earth is doing that, but that's how it's described. As every situation is relative to the observer. Okay, that's a big part of the theory of general relativity. And they solved this with a mathematical equation. How does a mathematical equation, Pierre, if you're watching this, please explain to me how a mathematical equation can solve something like that, unless the origin of the problem was mathematical to begin with. The only way a mathematical equation can solve a problem is that if the origin of the problem is also mathematical. If you do not need to add any real physics into the mix to solve the thing, then it's mathematical problem solved by mathematical solution. This is pure pseudoscience. It's not real. We'll carry on. What a lot of people are not aware of is that Albert Einstein's theory of general relativity actually works better in a lot of ways with the Flat Earth Society's model of an upward flying disk outside through space, creating a downward effect calculated, not measured, calculated as 9.8 meters per second squared upon it. Okay, so I just want to show here that this 9.8 meters per second squared, that's little g, it's a calculated rate, calculated originally by Charles Vernon Boys in the late 1800s, if I remember correctly, it's 1892 or something like that, or 1888, it's close to that, I think, if I remember correct. Albert Einstein's theory of general relativity, for some parts of it, work a whole lot better on the Flat Earth Society's pizza flying upward through space model. Because the ground is coming up to meet everything in that belief, this pizza flying through space belief that this Flat Earth Society have. The ground is doing that. It's constantly moving up the way at 9.8 meters per second squared. So that that is an interesting thing, that Einstein's theory of general relativity works better with that. But we'll carry on. Now, no, and this is important, no flat earthers, modern or old, actually promote this model of an upward flowing disk earth, as it is held that we are stationary and enclosed and not an open and moving system, like the globe and flat earth society models. But it is curious that Einstein's general relativity model would not have to have created a mathematical equation for the problem of two objects falling simultaneously in different locations on the flat earth society's model of earth, as in that model the floor would always be coming up to meet all objects. I have seen writings that stated that Einstein himself was interested in the flat earth society model of an upward flowing disk earth, but I do not have those writings myself, so I cannot confirm this as a fact. It's something that I have to get. I've seen them, but because I don't have them, I don't want to assert it as fact, because if someone says to me, show me the details, I don't have them right now, so I can't show it. But as soon as I do have them, and I can confirm them as real, then I can do that. Why is all this important as a response to Pierre-Marie Robitaille's debunking of Dave from the Professor Dave YouTube channel? Yeah, Dave, because Dave is not a professor. He calls himself Professor Dave, but Dave is just Dave. Pierre, if you're watching this, in the flat earth arena, we refer to Dave, Professor Dave, as just Dave, because he's not a professor. And he admits this himself, but he still calls himself Professor Dave. You know, so I can call myself Professor Brian, even though I'm not a professor. You know, I can do that online, because online you can be anyone you want. Dave is a professor, pretend professor, but he's not really a professor. But he pretends to be a professor. So just wanted to point that out. So this is all important to everything I'm after reading so far is important, and I'll explain now why. Okay. It's vitally important, as we must establish what is actually the mainstream's currently held belief of what gravity is, what it does, why it does it, and how it does it. As then we can establish whether or not we are working within those very specific parameters given to mainstream science by Albert Einstein, and not referring back to an older description of gravity or previously held beliefs. Now, all of this is working within the heliocentric model, something I am obviously opposed to, but I must be specific even when I am speaking about or referring to the heliocentric belief, as that is how we dismantle or support it. Professor Dave does not do this. Okay, Professor Dave inserts gravity as a force many times. He's always doing this, and many others on that we argue and fight against. He is pushing pseudoscience, for one, but he's also inserting a description of gravity that has been out of date since 1915, 105 years ago. Now, he is attacking Pierre. He's attacking Pierre, someone who is definitely more accomplished. And he's trying to insert, as part of his reasoning, for things like why, let's just say, why the sun can be a ball of plasma, helium and hydrogen plasma. It's because of its attractive forces within the gases. It creates a massive mass, and all these, like, and there were several times, I can't remember all the exact details, but he's basically adding in what would be Cavendish era gravity, something that has been not the mainstream held position on gravity since 1915. There was many times during the video, and I've heard him do it in the past, where he adds this in. So he does not stick to the specifics. Albert Einstein gave the world the theory of general relativity. Now, I have no interest in it. What I mean is that I do not agree with it, or I do not follow it. I think it's pseudoscience, but it is the currently held model and description for gravity. And Dave, some people, if he wants to call himself Professor Dave, not Professor, doesn't seem to want to be specific. He wants to hark back to a Cavendish era gravity, or what he might call Newtonian gravity. That is not really Newtonian gravity. He wants to assert mass is attracting mass, and there's an attractive force, when there isn't. It's an effect, not a force, described by Einstein and stated by Einstein as an effect, not a force. In the response video that Pierre made, it was obvious that Professor Dave views gravity as a force of attraction between masses of differing sizes, something it is not described as and has not been described as since 1915. So Professor Dave and Pierre, you included, if you state gravity to be a force, I don't know if you do, you are both incorrect. It is officially described as an effect and not a force. Something that is important that I must point out, and that is that Einstein never clearly defined what he meant by the word effect when referring to gravity as an effect. He also did not clearly define what he meant by the term mass, as mass has several definitions. Mass is defined as matter, density, volume, and mole. Mole can be mass. So, which one Einstein was referring to, I do not know, right? So there's two problems here. Einstein never defined the word effect, what he actually meant by when he called gravity an effect. He never defined it. So it has loose parameters. So people like Professor Dave will switch back to calling it a force. I've even heard it being called, an emergent force, which is actually a secondary entropic force. It's been called that now by our opposition, by the opposition on the globe side to the flat earth. There seems to be a lot of people like Dave who keeps on wanting to push this gravity as a force thing. It's not. It's defined as an effect. It's described as an effect by Albert Einstein, but he doesn't clearly define what he means when he says effect. But he certainly doesn't mean force, because if he meant force, he would have said force. So what he means by effect, he didn't really define, right, for whatever reason. But he doesn't mean force, and he doesn't account for more than one mass in his theory of general relativity or in his 10 field equations. He does not account for more than one mass. So he is not talking about a force of attraction between masses. He does not mean that since 1915. He also did not clearly define what he meant by the term mass. He says that gravity is an effect caused by the curvature of space-time, which is mathematical, by mass. Now, some people will say by matter, and I even fell into that trap myself at one time, but mass is defined, if you want to define, like you look for matter, it'll be defined as mass. Density will be defined as mass. Volume, mass. And mole, which is a calculation of an amount of matter, is defined as mass. So everything is defined as mass. Now, I have my own thoughts on mass. As far as I'm concerned, I may as well lay it out here, as I made a video about it. As far as I'm concerned, mass is defined as all the things that do create, that are responsible for weight. But if you look for the definition of weight, the definition you will get is gravitational attraction. You might get mass times gravitational attraction, but most of the time you'll just get, if you want to define it clearly, you'll get gravitational attraction. The word mass won't be involved at all. It can be involved, but it doesn't have to be. But yet, what defines weight? The density of matter within the confines of the volume of an object or substance defines its weight. If you want to measure, if you want to weigh something, its weight is defined by the amount of matter, the density of matter that's within the confines of its volume, whether it be an object or a substance. And these are all the things that mass defines. But when you look for the official definition of weight, you get gravitational acceleration. Little g, that's what you get. So as far as I'm concerned, the word mass basically is like a barrier that keeps all the things that do create, that are responsible for weight, that are responsible for the cause of weight, that are the cause of weight. It keeps all them away from that officially, and weight is then defined as gravitational attraction. So, the word mass is the defining of it in general is a mess. And Albert Einstein certainly didn't define it clearly in his theory of general relativity. And he never defined the word effect when he's speaking about gravity as an effect. He didn't clearly define what he actually meant. All we know is that he didn't mean a force of attraction between masses. We know this. So carry on. So this leads us to a very important part in this video. What is the difference? This is very important. Now, Pierre, if you're watching this, you might be thinking at this stage, this is just somebody giving out, or you may or may not agree with me. And I'm okay if you don't agree with me. If you want to speak with me about it, I'm open for that too. And you're okay, it's okay if you don't agree with me, I'm okay with that. But what's the best way to say it? I am staunch in wanting to know what is real and what is not. So if you're not as staunch as me, even though you have such education behind you, then speaking with me about things like this could be good or it could be bad. Okay, but I'm open to it. What is the difference between a colloquial theory and a scientific theory? This is of the utmost importance now in the world, more than ever before. Why is it so important now? Because more than ever before in the world now, we have more pseudoscience going on and being pushed as reality than we ever have before. We have diagrams and CGI being given to us, and we're being told about stuff to do with this a vacuum of the sky that is supposed to, all this stuff is supposed to happen out there. Now, as a flat earther, obviously, I don't believe any of that. I fully believe, I fully know we are enclosed, as this place cannot work any other way. But there is so many people out there in the world who take in this stuff as actual science, when all it is stories made originally from observations of what people thought the sky was, and what's the best way to describe it? And kind of a carry on from that. They now give people, instead of stories so much, they're giving people CGI. They're giving them fantasy to believe in. So that's why it's more important now than ever to know the difference between a colloquial theory and a scientific theory. It's more important than ever for people to understand this now. A colloquial theory is a generalized theory on anything, from why did your fridge stop working to what creates a rainbow. It is something that has not been put through any specific method of inquiry. It is open to interpretation and change. So anyone can have a theory on anything. There could be 10 people with 10 different theories on the cause of something. It doesn't mean that they're all correct. It means it just means there's 10 theories. So a colloquial theory is just a theory. That's all it is. It hasn't become anything more than that. So that's a colloquial theory. Whereas a scientific theory has a very definite definition. It is a theory based on a naturally observed phenomenon that has had its positive hypothesis proven correct and its null hypothesis proven incorrect when put through a hypothesis test. What is a hypothesis test? A hypothesis test is a scientific experiment that adheres to a scientific method strictly, very importantly, so as to make sure that all outcomes are honest, repeatable, and true. Okay, that's very important. So what are the steps of this method? Excuse me. Okay, step 1, observe a natural phenomenon. This is the observing of something in the natural world that is not understood yet. Okay, so you see something, you don't know how it happens, why it happens, whatever, in the natural world, right? And you want to find out what caused this effect, okay, this phenomenon. Step 2, state your positive hypothesis. What you believe to be the natural cause to the naturally observed effect you witnessed. So step 2 is stating what you believe to be the cause of this. Right, so what I think it's this or that is the cause. I think it's whatever is the cause of whatever. Okay, that's step 2. So the first 2 steps everyone does. So they see something and then they go, well, I think it's this, or I think it's that. So they see a phenomenon and they go, I could say I think it's this. Someone else could say they think it's that. Right. So people do these 2 all the time, but it's from this moment on is when it really becomes strict. Step 3, state your independent variable, that which you will manipulate during the experiment, your presumed cause. So it's at this point where you are stating what your very definitely what your independent variable will be. Independent means it's on its own. It'll be one thing and one thing only that you will manipulate within your experiment, your hypothesis test, to hopefully show the effect, the phenomenon that you witnessed naturally. So that'll be your independent variable. Okay, that's your independent variable. It'll be one thing only, and you will manipulate that one thing only. So you're going to find out a definite cause. You'll find out for definite whether or not your positive hypothesis or your null hypothesis is correct. Step 4, state your dependent variable. Excuse me. That which you expect to see by manipulating your IV, your independent variable, the expected effect. So step 4 is you're stating what the effect is that you're expecting to see. The phenomena that you originally witnessed, that is what you're expecting to see when you manipulate your independent variable, your IV. Okay, your DV, your dependent variable, is the effect, and the IV is your cause. So you manipulate your IV to hopefully see the DV that you witnessed as a phenomenon. Okay. Step 5, state your control variables, that which you intend on keeping constant and unchanging during the experiment. So your control variables will be the things that you won't be changing. They will stay constant all the time throughout the whole experiment. They won't be changing, they won't be manipulated. You won't do anything, whether it be temperature, times, whatever. Right? You're going to keep it all constant. Time is always a constant. It's always a control variable. But temperature, you might want to keep a particular temperature or something like that. So you have state the things that you kept constant throughout your experiment. So anyone who wants to repeat it will do the exact same as you did. And so they can, to see if they can replicate what you did, to support or defy your experiment as being correct. Okay, step 6, state your null hypothesis, that which is the polar opposite of your positive hypothesis. So if your positive hypothesis is A, then let's just say your polar or null hypothesis is B, right? So if it's not A, if you're basically it means if you're stating something as the cause, as your positive hypothesis, and it turns out not to be your cause, then your null hypothesis has been proven. That means you have proven that what you thought was going to be what your independent variable was, what you thought was the cause of the effect you witnessed, the phenomenon you witnessed, is not the cause. So your null hypothesis is stating that your positive hypothesis is not the cause. So either way, you always prove something. You either prove something is the cause, or you prove that that same thing is not the cause. So then you can rule that out completely from your investigations. So one or the other. It's always the positive or null is always validated, always within scientific method. Okay. Step 7, perform your hypothesis test to determine whether your positive or null hypothesis is correct. So 7 is the actual hypothesis test, the actual science experiment. When you do this, you find out whether your positive or your null is correct. So if your positive is proven incorrect, then your null is proven correct. If your positive is proven correct, then your null is proven incorrect. Pretty simple, very straightforward, but very strict, because it has to be. This is why it's not sticking to these things is the reason we have so much pseudoscience in the world. Step 8, state your final results. So they can be reviewed, repeated, and demonstrated by others to confirm your results as true, honest, and dependable. So you state your results. You state all the things you did, what you kept constant, your independent, your dependent variable, all those things, and then others can review and then repeat and demonstrate what you did. And if they can get the same results and it all works out the same all the time, then you can be shown to be dependable, that what you confirmed to be true is true, or what your experiment showed to be true is true. It's honest and it's dependable. We can go forward then, we don't have to, that will never change. The boiling temperature is the best example because everyone knows this one. The boiling temperature of water at sea level was proven this way. We never have to find out that again. We know what it is because it went through scientific method. We don't have to go and change that in the future. It won't change in the future. The boiling temperature of water at sea level will always be the same because we found out what it was. We found out why it was through scientific method. Everybody understands that, so it's the best example. Now, the reason I add these above writings to this video is because of the level of pseudoscience that has been demonstrated by Dave, not a professor, but also to highlight some things that I feel you, Pierre, if you're watching this, should give thought to. Now, these are the points I was talking about earlier about the video. The most important points in this video response from Pierre to Dave that stood out to me were: 1. Dave's obvious lack of respect for Pierre, someone who was far more accomplished than Dave is, and this hate seemed to spawn directly from Pierre using sense. Pierre is just stating PV equals nRT means the sun cannot be a ball of gas or plasma in a vacuum. You know, that is that. He's just using sense. It's just like, this is the way it is. If anything that's constant here in the world, now, on the ground, has to be constant anywhere else. That's the way it is. There's certain natural laws, and they don't change. Excuse me. I get over something. 2. The lack of understanding when it came to PV equals nRT, as Dave seemed to be denying that it is a law that holds true always and everywhere, regardless of the situation. Gas pressure will never form in a vacuum. Dave doesn't seem to understand that PV equals nRT is true for gas and gas behavior at all times, regardless of where you want to believe the gas is. I obviously, as a flat earther, have no belief in a sky vacuum, but Dave does. And Pierre obviously does believe this too, from what I can gather. But gas pressure will never form in a vacuum. That's not what happens. Neither will any kind of plasma. It won't happen. It's a complete impossibility. Pierre is 100% correct when he states, and I guarantee you in the future, he will get a lot more praise from science, from mainstream science, simply because he's just telling the truth. PV equals nRT debunks all notions of helium and hydrogen making up stars in the sun and all these other things, because that doesn't happen. It won't work. It's a vacuum. That's not how vacuums work. In vacuums, gas does not decide to come together and be a light, and decide to be a fusion reactor. A plasma fusion reactor. That's not what happens in a vacuum. That's not how gas behaves. That is just the way it is. These are facts. But not a professor, Dave, just doesn't seem to want to accept these things. And he's attacking Pierre, who is just being honest. But Dave is just a fundamentalist believer. He's somebody I view as having a sickness. He's got a religious belief which causes him, I would view it as a sickness. He has a belief sickness. And he's very rude and very arrogant. Yet he never debates anyone, and he's not respected like he thinks he is. He's only respected by people who get confirmation bias from him. He's not respected in flat earth. We don't respect him at all. He's not one of the globe opponents that we respect at all. He's not seen with anything other than just being an arrogant fool who constantly will get things wrong. Yet he's attacking someone who is on his side, which is Pierre. He's attacking Pierre because Pierre is just telling the truth. Because that truth goes against what Dave wants to be real. And what Pierre is saying just happens to be very similar to what flat earthers are saying and have been saying for years now. But Dave does not like this. 3. Pierre is calm demolishing of Dave's attacks. Pierre was very, very well-mannered, and he was very well-mannered, and he was calm, and he took the attacks apart. He saw a lot of them as being childish. Basically, anything that Dave had to say, Pierre completely debunked. It showed that Dave didn't know what he was talking about. When he was talking about any subject, Dave didn't know what he was know what he was talking about. Pierre did know what he was talking about, and he basically made an absolute I mean, Dave should be ashamed. I mean, he shouldn't show his face online for months. I mean, it's horrendous, absolutely horrendous. But Pierre is somebody who is accomplished. He did do some real things. So, and what he's speaking about is true. But Dave obviously can't handle this. And Dave is a very hateful person, and he'll even attack people on his own side because Pierre is saying things that Dave has heard flat earthers say for a long time, and he doesn't like it. He does not like us at all. He obviously has a problem with flat earthers because he's constantly mentioning us. And he even likened Pierre to flat earthers as a way of putting Pierre down, because Dave likes to try to look down upon flat earthers, yet he will not debate us. Strange that. 4. The seemingly obvious reliance that the globe model has on gravity as a reality. This is really important, this point. For Pierre, what actual solid evidence is there for gravity? I mean, if you take gravity away, then how is there a globe model? How can the globe model exist without gravity? How can all the waters that we are told as we grow up that are clinging to a rotating globe, how can they all stay there and be there? How can we have, like on the globe model, you can't have gas, what people like to call atmospheric pressure, which is only gas pressure. Calling it atmospheric pressure doesn't change that it's gas pressure. But without gravity, there's no explanation for that on the globe model. There's no explanation for water sticking to the globe, especially a rotating globe. So there's massive reliance on this gravity. But what evidence is there for this thing? What evidence is there for gravity? Pierre, you are probably not aware, but we on the flat earth side have already completely and utterly debunked it. And we've explained the whole lot with relative density equilibrium. The whole lot is explained. And buoyancy is explained by volume, area, design, and displacement. Totally explained. No need for gravity. And this is a problem with the globe. You hold on to this gravity. You can't let it go, because as soon as you let that go, it means you let go of the reality that you've been believing for a long time. But it's time to let it go. It's either prove it or let it go. And I know you can't prove it, because if you could, you would have already done that. So Pierre, you are somebody who is obviously using logic. You're obviously using your mind. So why continue holding on to something that's a glass hammer? It will never be any good for hitting nails. I'll move on. 5. If the sun gives us a continuous spectrum, then it is not a gas nor a plasma. People need to understand this. Pierre has been trying to say the same thing as what we've been saying in Flat Earth. If the sun is given a continuous spectrum, it doesn't mean that the sun is a solid. We don't know what the sun is. I don't make a claim on what the sun is, or what size it is, or how high it is, or any of the rest of it. I can only talk about what it appears to do within its cycle on a yearly basis. That's it. I don't know what the sun is. I'm not saying because there is a continuous spectrum when they use stellar spectroscopy on it, they get a continuous spectrum, which can only come from a solid. It cannot come from a gas. It does not come from plasma. It can only come from a solid. So Professor Dave, and all the people out there like him have to start just accepting if they're getting a continuous, if you're getting a continuous spectrum from the sun using stellar spectroscopy, I have to get throat is dry, then it's not a gas and it's not a plasma. That is the way it is. You would never get a continuous spectrum from a gas or a plasma here using terrestrial spectroscopy within a controlled environment, within a machine worth about $120,000 that's designed to keep the environment sterile and controlled. You will never, ever, 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 ever get a continuous spectrum from a gas or a plasma, but you will get it from a solid. So if that's what you're getting when you're using spectroscopy with the sun, then the sun is not a gas or a plasma. End of story. There is no argument. Pierre is correct. You need to change your whole model and belief about what the sun is and the rest of the stars if you're believing them to be the same. Okay? 6. Quick sip of water before I do this because we're almost at the end here. Helium and hydrogen are the two least dense forms of matter known. So if these two elements are the most picked up elements in our upper sky by stellar spectroscopy, this does not mean that the sun and stars are made of them. This is a very important point. The two least dense forms of matter we know is helium, and then the least is the second least, and hydrogen is the least. Now, above the homogeneous layer of the atmosphere, things supposedly start to layer themselves, gases start to layer themselves through density. So at the upper echelons of our atmosphere, you're going to find helium and hydrogen. So if you're using stellar spectroscopy, then the last things that you're going to encounter, the last elements you're going to encounter will be helium and hydrogen. So that does not mean that all the lights in the sky that you're seeing are made of these. The whole of astrophysics has made a big story about all this helium and hydrogen that's supposedly out in this place they call the universe, and they end up becoming the hydrogen and helium ends up becoming big massive reactors, fusion reactors that we call stars, and there's all this big story about it. No, they're the least dense matter we know of, so they end up higher at the end than you're not going to find carbon dioxide up there so easy, because that's a lot more dense, or oxygen, that's more dense as well, and that's cycled closer to the ground. Whereas helium and hydrogen, you are going to find them up there. So just because you find helium and hydrogen, or what seems to be helium and hydrogen through stellar spectroscopy, which I have to add, is not done under controlled conditions. Okay? There's all kinds of nonsense added into stellar spectroscopy, including at times the use of supposed satellites, right? That's another argument. So stellar spectroscopy is not done under controlled and sterile environments. So if you're picking up helium and hydrogen at the very, what you think is God knows what distance away, how do you know you're not just picking it up in the upper atmosphere? How do you know that just because you're picking it up and then you're picking up something to do a continuous spectrum on the sun, that somehow this helium and hydrogen is what the sun is made of? How do you know it's just not around the sun? You don't know what the sun is. Nobody does. It's just people think they do, and they make up stories. And that's pseudoscience. That's why I included the scientific method in this. That is not pseudoscience. But anything that has not gone through scientific method in the world of what they call science is automatically, by definition of the word, pseudoscience. So finding helium and hydrogen up high does not mean everything is made of helium and hydrogen up there. You don't know how high up high is. It could be several miles. It could be thousands. It could be it could be 20,000, or it could just be 100. Who knows? But this one does not mean the other. 7. So Pierre, this is for Pierre. If PV equals nRT is true and correct, then why do you not seem to apply the same ideal gas law to the Earth? If we have, Pierre, if we have gas pressure here on the Earth, it's not enough that the gas can bounce off the surface of the Earth. If we have a vacuum that is as low as 10 to the minus 17 torr outside of it, that isn't, you can't apply PV equals nRT to the sun and say that debunks the sun being a ball of helium and hydrogen plasma, and then just accept what they call atmospheric pressure as something done by gravity and the surface of the Earth. That's not how it works. Gas pressure needs a container to have the pressure. You cannot have gas pressure without a container. PV, volume. Volume of what? Of the container. What's the volume of the globe Earth's container? The vacuum of space. That's the container. So in the very diagrams that was shown within your video, showing what happens when gas gets a chance to fill the volume, that it just fills the volume. Why is the gas that we breathe not filling the available volume? You need to think about this. How can we be breathing this gas here and it not fill this supposed vacuum of space? You must give that some thought. Something is wrong if you think that we can have gas pressure without a container, because there is no container. Gravity is not a container to contain a gas, right? Even if not that gravity is real, but even if people try to assert that it's real, you have to have something that's made of plastic, glass, steel, something that's solid to contain gas. Something that's that dense to contain gas. It has to be at least as dense as plastic. What is the density of gravity? First, you'll have to prove it's in existence. And remember, according to mainstream science, since 1915, it's just an effect. And that effect is not clearly defined. And we still don't know what mass is. Don't forget that either. Okay, last part. This is why I spoke about theories, colloquial and scientific theory, right? Number 8, gravity is a colloquial theory and not a scientific theory. Very important. Gravity never went through scientific method. There is no hypothesis or hypothesis test available for gravity. The only experiment that people call an experiment is not an experiment that is ever put forward for gravity is the Cavendish, what they call experiment. But it is not an experiment. It was an observation made over the course of a year. And people, since Cavendish did this observation, Other people have tried to replicate it, and it is not replicatable. And Cavendish himself states that any movement that might have happened within his apparatus may not have just been due to tension on the wire. I can't remember the correct term for it now, but you won't understand it when I say tension on the wire. But also convection. He also states that convection could have caused any movement that may have happened, might have been caused by that very easily. So even Henry Cavendish himself didn't state that there was a gravitational attraction going on. And his what people call the Cavendish experiment, well, it wasn't an experiment, he wasn't trying to prove gravitational attraction. He pre-assumed it as a reality before he ever did it. What he was trying to do is determine the density of Earth. Now, I don't know why he was trying to do that or what was the point of that, but that is what he was trying to do. He wasn't trying to prove gravity. So, there is no hypothesis or hypothesis test. Not today, and not yesterday, and there won't be one tomorrow for gravity. Isaac Newton says himself he never feigned a hypothesis. He never put a hypothesis forward for gravity or anything else. And he even in a letter to, I think it was a man called Dawson of his time, a philosopher, he wrote a letter stating to this man to stop saying that he, Isaac Newton, was claiming that there was a force, a magic force of attraction between masses, whatever mass is. He said to state this, he said, I can't remember his exact words, but basically the gist of it was to state this is craziness, and anybody of sound mind would think so. So even Isaac Newton didn't state that mass was attracting mass publicly at that time. Not when he wrote that letter. I don't know about any other time, but not when he wrote that letter. Henry Cavendish, who came after him, wasn't trying to prove gravity. He pre-assumed gravity. And then he used this pre-assumption within his apparatus to do what he was trying to prove, which was calculate the density of Earth. As I said, I don't know why he was doing that. After his time came Charles Vernon Boyce, who calculated little g, which is 9.8 meters per second squared. And all this was thrown out the window some years later, and it was in the late 1800s. Then in the early 1900s, all this was thrown out the window by Albert Einstein with his theory of general relativity, taking away the mass attracting mass and making gravity an effect. And as I said earlier, he didn't define this effect. He never defined what this effect was supposed to be. He just said it's not mass attracting mass, not a force of attraction between masses, an effect. And he didn't define what he meant by mass either, but we already covered that. But he didn't put forward an hypothesis either. So gravity has never had an actual hypothesis put forward for it, or has never gone through scientific method. It never went through a hypothesis test, because there was never even a hypothesis put forward for it. So how can the whole world and all of mainstream science rely on this thing that was never ever proven and validated? Please, Pierre, you seem like a logical guy, and you obviously know the reality of making something real as opposed to not making something real with your accomplishments. So please give this a bit of thought, as opposed to hand wave it away because a flat earther who left school at 15 or before that is saying it. As I said at the start, that does not make me incorrect. Okay, hopefully you'll watch this, and I won't get too much trolling on it from other people. I would like a reply from yourself of some kind, just some acknowledgement of what that you saw it and what you thought of it. I know it's pretty long, about an hour or so, but it was necessary to say what I said. That's the end of that. I hope that it'll be enjoyable for anyone that watches it and educational. Thank you.